Okay, so this is an example in chapter 7 involving the probability of x bar being bigger than some number or lower than some number. But this is the opposite of the typical question, because the typical question, they tell you the number and they ask you to find the percentage. And now Julie asked me to do the opposite type of kind of question, which we haven't solved in class before, and we haven't had, it's the first time we have a video of it, of where you're given the percentage and try to figure out the number. So it's basically just reverse the steps. So it's not really conceptually anything, but let's work it out. So before we do, the way we work out every example in chapter 7 is by making a series of 3 pictures. The first picture represents the population. The second picture represents the averages, which was definitely a bell-shaped curve. And the third picture represents the Z diagram where you do all your practical calculations on. So we call the first one the population picture. We call the second one the sampling distribution of the mean. And we call the last picture the Z picture. The symbol that we give, the last one we called the standard normal distribution, just putting down terminology and and each of them have their own symbol. The first picture we call X, representing individuals. The second picture we symbolize by the X bar, representing the means of the samples. And the third picture we symbolize by Z. Now the shape of the first picture doesn't make a difference. It could be a rectangle like we had for the spinner assignment. It could be a bell-shaped curve. They tell you that, but it doesn't make a difference. But what is important about it is knowing 3 things. What is the average of that population? What is the sigma of that population? And what is the sample size that we're taking from that population to create the averages? So this, we'll be filling in those 3 numbers in a second. The second picture, according to the central limit theorem, is definitely a bell-shaped curve under most circumstances, including for our chapters, with 3 properties. Its overall shape, which we just said is a bell-shaped curve. Its middle value, which we're going to symbolize the average among the averages, which will be the same number as this number, as we know from before. And finally, the only thing that's really different compared to chapter 6 is something called the standard error of the mean, which is sigma sub x bar, which means in English how much the x bars deviate from the ideal number as you'd expect this number to be. But we also expect some deviation. That can be predicted or projected as sigma over n. And eventually we're going to go to a third, the Z diagram, which we know has also 3 properties: a bell-shaped curve, middle value of 0, and a standard deviation of exactly 1. And we're going to go from this picture to this picture in order to do the calculations by the formula. Z equals not the formula from chapter 6, x minus mu of a sigma, even though that would work for us technically. It's now updated to x bar minus mu of x bar over sigma of x bar. So now we have the material that's going to be useful for every single example in chapter 7. And now Laura can give me the numbers from homework number 7.1 of the online material. But of course the online material, every time you do it, there's different numbers, so you may have different numbers, but we'll use the numbers you give me right now. So what's the average of the population? No, I'm sorry. You asked me that. I'm sorry. Julie asked me that. I'm sorry. I'm not saying Laura. Julie, I'm sorry. So the sample is 16. 1.31. 0.08. Okay. And a sample is, so if the sample size is 16, we know that the middle value will still be 1.31. We know this will be 16. I'm sorry. It will be 0.08 divided by the square root of 16, which comes out to, I think, 0.02. Again, comes out to 0.08 over 4 is 0.02. So this number here is 0.02, and this here eventually will be 0.02. We can put it down right now. Okay, but what's the question now? How is 51 or 61? 5-1? So the probability is that what? 51%. Okay, so let's first work it out sort of roughly by, without a formula, then we'll work it out by a formula. If I told you that how much between, now where is this number? Where I just made this little picture, where is that number right now? If this is I'll pick on you, Ada, Julie. since you asked me the question. If this is 131 and this is 0.02, where is my finger at right now? How much is 1.31 plus 0.02? What? Very good. Okay, 1.33. And if I went a standard deviation in this direction, how much is 131 minus 0.02? Very good. You'd be surprised how many people can't do that. Okay, 1.29. So if I ask you, what's the probability of having an X bar between, this is the question, of having an X bar between 1.33 and 1.29? What would be the answer? Knowing that from here to here is how much? Remember how much is that piece? Remember that chunk I told you to memorize? What will be that chunk? One standard deviation of every in any curve, any bell-shaped curve is how much? Very good. 34% is here, 34% is here, and therefore how much is between here and here? I'm sorry, it should be a positive 129, of course. 129 to 133 is what percentage? 68%. So the answer that we're looking for with the question is not 68%, but 51%. The answer's got to be closer together or further apart than these pair of numbers. Closer together. So theoretically, could you do this by trial and error? You could try 132, 130, 132.05. You keep trying with different pairs of numbers. Every time you convert it to a Z diagram, Julie, and each time you figure out the percentages till eventually you want what? You want that between one number and its other number should contain what percentage? What percentage is the book telling us to contain in this piece here? 51%. So this piece here is 0.51. So instead of going by trial and error and working, basically the trick to save some time, to save some tape, you basically figure out which is the Z number that chops off 51%. That gives you a Z, let's say 1.37 for argument's sake. And then you plug it into the formula and you solve for the unknown. Because what's the unknown here? The unknown is the X bar. Like, what is that X bar? Is it this one, this pair of numbers? No. It's not this. We just said that's 68%. That's not 51%. We got to be a little bit closer together. So the steps involve the following two steps, basically. First, you go to the back of the Z table and you ask yourself which Z number chops off between itself and its minus, like it's 51%. Now, in what chapter have we seen that, Julie? Where we're given a percentage in the middle and we ask what's the Z number that chops it off? That was the thing for Chapter 8, the other half of the test. In fact, 2/3 of the test, where it's saying find a 95% confidence interval, find an 85% confidence interval, find a 99% confidence interval. So how do we do that? If this is 51%, how much? Remember, the Z table focuses on the end of it always. So what's the piece over here? If this is 51%, how much is on the missing outside? So remember, we did exactly the same thing in Chapter. So after learning Chapter 8, Chapter 7 is easier. What? So it's 51. So the outside is 49%, but we have two pieces, so it's really 40. What'd you say? 24.5. Yes. So 0.2450. So this area is 2450. So I'd like for those who would like to cooperate to look up 24. Yes. So if you look up negative 0.69, you're going to find the area to the left of that is very close to 2450. And everybody who wants to play at home can do that. Look it up in the Z table, make sure you find it. How much is to the right of 69? Also 24.5%. That's irrelevant because we really want to know that this number here. So the Z-score in this particular case that's going to satisfy our information or our requirements or our question is negative 0.69. So what is the unknown in this particular problem? Is the mu the unknown? No, the mu we know is from the first information has to be 1.31. So let's put a 1.31 there. Is the sigma of X bar an unknown? No, we calculated that. That's given to us. We know it. The only unknown is the X bar, which in this case is like the X of the algebraic equation, and you solve that equation. How do you solve an equation like this? Those of you who hope still remember this. You cross multiply, and then you bring it to the other side of the equation. So the X bar, after all is said and done, will be negative 0.69 multiplied by the 0.02. Let's put parentheses here. And then we have to bring the other side of the equation of plus 1.31, which if anybody takes out a calculator, you can tell me the answer and I'll be glad to show it to the rest of the class. So again, we're using cross multiple. We're solving basically an algebraic equation, which hopefully you still remember how to do.